Morning, everybody.
More.
Morning.
Um, just 1 second.
Good morning.
April 27th. Holy cow. Oh, man. All right. We've got one of those.
Lay down.
No. Okay. I want to go through the final exam for you guys so you can start thinking about it and preparing and asking questions if you think there's something you want to go over again. This one here, I'm going to share. Can you see my shared drive?
Yep.
Okay, I put on the main page, Electech 232 final exam. I'm probably gonna dial this in a little better, but we're gonna sign up for times. You'll have 2 hours to program the controller and create this logic. The program's gonna have a rung showing degrees Celsius from the temperature probe, a rung showing degrees Fahrenheit, both of those assigned to an F8, a rung showing fan speed in Hertz, assigned to an F8. Stop start using the push buttons on the trainer that energizes the temperature heater.
Hey, before we go any further, so just because we're there, so you're gonna be nice and not make us display it on the 3 segment that is reverse polarity.
No, we're not doing that crap.
All right, perfect. That's all I wanted to ask.
Thanks, Nathan. Start stop energizes the temperature heater. That's just the soldering iron. As the temperature that the thermocouple reads goes up, the 3-phase exhaust fan speeds up. When the temperature heater is on, a red pilot light is on. All rungs must be labeled for their specific function. Okay.
Okay.
The only thing I'm not sure yet is how mean I want to be as far as I probably have all the inputs labeled like in the tags for you already. I do want you to set up the controller. I'm going to run through this and like create the program itself and see how long it takes me to do it. If it takes me 3 hours to do it, then I'm not going to, but I don't think that should take you that long if you've been paying attention. So any questions on that, doodad?
Nothing technical wise. Do you have like an idea of like how we're going to schedule out when we're going to do the final exams though?
No, I mean, I understand some of you are working, so I got to figure out which days we're doing it first.
Okay.
Because I haven't heard like when the official exam week starts. So I'll take into account if people have specific work schedules they need to work around, those people have first dibs. And then from there, we can either decide together or we can draw a name out of a hat. I don't really care. And then we'll do it just like how we've been doing it in class, where you'll have control of my screen, and then I'll sit there and fall asleep while you're writing your stuff, and then you'll wake me up and say, okay, I'm done, and we'll try it out. And it's designed to have the same point value as if you had done all the labs. So that's what I'm going to base your grade on. You know, if you accomplish X amount of tasks, then, you know, you get points for that amount. Okie dokie.
Okie dokie.
That's good to
Yeah.
me.
And then the rest of your grade, overall grade, will be determined by your attendance and participation, all that jazz.
Well,
Huh.
so I did several of those labs. So does that not account for anything then?
Yeah, if you show up on time the other day, I'd explain that to you.
Yeah, I'm sorry. I'm a busy man, Zach.
You know, it's okay. So what happens is there's a couple of you that completed all those labs, right? The only way that there's not enough time for everybody to sit down and complete their labs using my software under remote access. So if you've done all the labs or you've done most of them and you're okay with that grade, basically you can choose to do the final or not, right? If I'm either going to go off your lab grade or your final grade. So if you want to try to do better than your labs, then you can obviously want to take the final. And then whatever happens, if you have, 90% of your labs done, that's an A grade, and you want to try to get, better on the final, and you only get 80% on the final, I'm going to take the better of the two. So you can't do worse by taking the final. You know what I mean?
All right. So with that being said, though, you've got some labs marked in there that we were not going to do. So how do we know where we even sit? Because there's labs like 1 through 20 or whatever.
I will tell you.
You know what I mean?
And
There's some labs in there that we were not going to do.
I'm pretty sure.
Are you looking at 231?
In front of the class that you have all of the labs done that are required, so you don't have to take the final, but you're more than welcome to. See what I'm saying? Hello?
John? It's probably
Yeah, I
time.
phased out.
Here's what I'll do. I'll put this on that exam. They can have it in writing, but trying to look here. If you've done 8, 9, 10, 11, 12, 13, 15, and 17, that's 100%. 8, 9, 10, 11, 12, 13, 15, 17. So that's 8 labs. Okay.
And would you be able to email those numbers to me? I'm on mobile at the moment.
Yeah, I'll put it on either or on Blackboard or something.
All right. Thank you, Zach. I don't mean to be a pain in the ass.
No, you're fine. Let me get it more in stone, get the schedule worked out, and I'll put it all together, and we'll go over it Wednesday or Friday. Because right now I don't even know when we're going to be taking these. But anyway, you'll have 2 hours to create a program that looks like what's on there on the shared drive. Capiche?
So have the dates changed, or you just don't know?
They have changed from the original.
The original, okay.
As they extended spring break, I'm pretty sure just all the final exam dates got
A
pushed
week back. Okay.
And that's another thing. When we start talking about signing up for a time to take your final, like a 2-hour time slot, you need to make sure you know when the finals for your other classes are, so you don't want to double book yourself.
Zach, do I have any other finals with you?
No. They're 231, the automation class, there's no final for that class. 230, your group trainer is just a presentation when you're all done.
All right, then, yeah. I have a more technical question about the final. What function would we use to, like, is there an equal to function that would let you change the, because I haven't really seen as the temperature goes up, you make the variable frequency drive also go up or down with it relative to it.
Okay, let's work through that problem as a class. So let's use a different example. Let's say that we're gonna use a different analog and like let's say the distance sensor.
Okay.
Let's say as the water in tank 2 rises, the single phase fan will speed up. Okay, that's the problem we're gonna try to create. So I'm gonna open whatever. Analog control example. 7. Let's get the program going here. Well, the first thing I need to do is I need to be able to control the pumps, right? So this processing can happen. So let's just use the selector switch for pumps 1 and 2. It seems like an easy thing to do. Say this is going to be selector left. And that's true. Oops. Left pump will energize for selector right will energize right pump. All right, so we have a distance sensor, so we have an analog input. And as that number rises, we want the number for the analog output, which is going to be the 4 to 20 milliamp signal on the single phase fan to go up, right? So we're going to have a compute function. And what other function are we going to need? What other type of instruction? Move. So what should we move?
Uh,
Sure.
the value of the thermocouple.
Well, we're not even using.
I mean, the distance sensor.
So the distance sensor is going to spit out some kind of number. What is the range of values you're going to see on the distance sensor?
Would it be the? I'm hoping it'd be the same 6100 to 32.
That would make it easy, but it's not.
Oh, is it 0 to 0 to 5 or 5 to 20?
0 to 31206.
Oh, okay.
So that distance sensor is a 0 to 10 volt signal. So the sensor is going to operate on 0 to 10 volts. When the PLC reads 0 volts, it's going to give you a number that looks like this. When it gives you 10 volts, it's going to give you a number that looks like this. Make sense?
Mm-hmm.
What do we need to output to the VFD?
0 to 60 hertz signal.
No. What is that drive looking for?
A voltage?
Nope.
No. Oh, that's my two guesses.
Isn't it?
6241 to 31207.
You're right, but what is that? What is that PLC monitor going to send, like signal wise?
Oh, 4 to 20 milliamps.
4 to 20 milliamps. We're going to output 4 to 20.
Never mind, Jacob got it.
And those numbers are what?
31206 and 61. I don't know.
And what?
6140. I'm pretty sure.
$62.41 to $31.206, I believe.
Yep.
Is that right, Zach?
Yeah, it is. Not just in the state, but you guys need to know this for the final, right? I mean, if you don't remember those numbers off the top of your head, you don't have to know where to find them online, right?
Correct.
Correct.
Okay, so that's what we need to do. Now we need to come up with the math to do it. So using this information for instruction are we going to use?
Would it be a compute function?
Yeah.
Hey, John, if you don't mind, could you mute yourself?
Yeah, who's making all the noise?
Tierney, how come you didn't mute it, kid? Sorry, guys.
You're good. So we're going to need a compute function. What are we going to compute?
That's I don't know.
4 to 20 milliamps into 6241 to 31206. You interpolate that so we can get that scale.
We do need to interpolate. Yeah. So we need to come up with a formula that's going to take one set of values and turn it into another set of values, right?
Right.
What's our first set of values? We just had them written down.
Is
From
it the
distance
0?
sensor? Yeah.
The 0 to 3, 1.
31206.
Mm-hmm.
0 to 31206 and
The 6, 1, 6.
6241.
41 to 31206.
Yeah.
Written down. It's just on another screen.
All right. So if your input is a range between 0 and 31206, I'm just going to use the letter I to represent that. So whatever that distance sensor is reading is going to be this I, some number, right? What do we need to do with that number to turn it into a value that's 31206 to 6241?
Wouldn't it already be that number?
No, because it's two different ranges.
Oh, I'm so sorry. You were saying to go to the other one. You'd. Let me look up the formula real quick.
Your input is going to be somewhere in here, right?
Mm-hmm.
We need to output somewhere in here.
Are you looking for a simple answer, like interpolate? Or are you looking for the formula?
We need to interpolate it, yes, but we need a formula because we're going to have to put it into our compute function.
So we'll take the distance sensor. Well, yeah, you're already writing it down. So we'll subtract 31206 minus 0 and multiply that by whatever we're reading on the distance sensor.
Yeah, so basically we're going to take the first range, we're going to turn it into a percentage. We're going to take that percentage and apply it to the second range, right?
Yeah.
So what is the percentage of the input going to be?
Should we give you just like a random number?
No, just using the variable I for input.
Oh,
Yeah.
The I minus the bottom number divided by the high number minus the bottom number.
correct.
Which ends up being just I divided by
H.
306. Right?
Right.
Yeah, so whatever that I would be the distance sensor in this.
Yep. So we're going to take the
Situation.
distance sensor divided by 31206. That gives us a percentage. And we're going to apply it to the other range. So how do we do that?
Um,
Could you repeat that? I was writing stuff down.
Well, remember our whole goal here is to take this percentage of the first range and apply it to this range.
Mm-hmm.
So we have our percentage. It's going to be the input divided by 31206. So how do we apply it to the second range?
We would just add 6241 to whatever number we're getting.
Eventually, yeah, but the first thing we do is
but-
multiply it times this range, right?
Yeah.
So times 31206 minus
6241.
Yep.
yeah, so the 24,965.
Yep, and you can either calculate it yourself or put it into the compute function. 31206 minus 6241. So that applies it to that range, but that won't give us the right number until we add it to the bottom number. Everybody get that?
Mm-hmm. And then you just put that formula into the compute function, right?
Yeah.
And then set the destination to the float 8,
Yep.
and then put that number into the variable frequency drive.
Yep. Exactly.
Okay.
So here's
And
your
then
formula. And then we're going to take that number and assign it to an F8. We're going to take whatever that F8 is and move it to the output of the drive. Follow?
mm-hmm.
Everybody good? Can I erase this?
Yes.
Going once.
Yeah, I'm good.
Would this also be the you can erase it still. Would this also be the same number that would apply to the that F8 for the variable frequency drive?
I'm not sure I understand your question.
So for the final exam, it says a rung showing fan speed in Fahrenheit to an F8. Would that be the same as the what we just did?
No.
No?
No.
Oh, because I didn't need to interpolate that into hertz. Okay.
Yeah. That interpolation was for, I mean, think about it in the two ranges. Think about the interpolation as two ranges, right?
Yeah.
Two ranges. Two ranges. Okay.
Gotcha.
Now, this range, make it a percentage and apply it to this range. So if we were doing that, if we were taking that, whatever signal this range was and applying it to this, what would this range be? This one. This
The end result.
the fan speed. So we would
Yeah.
this is 0 to 60, not 6241 to 31206. This would be 0 to 60.
Yeah.
Correct? So
Correct.
no matter which two ranges it is, you're applying one as a percentage to the other one.
Correct.
Capiche?
Capiche.
All right, so what am I doing with this compute function?
Put in the destination, which isn't that the VFD?
Now remember, this is where we're putting our formula. Let's do this. Let's put the formula in first.
Okay.
What is it?
So our input,
Okay, hang on. What's our input?
not sure.
Let me
Was it
look
one of the pumps?
The
It was the distance sensor.
Oh yeah.
distance sensor. That's right.
We changed it so we couldn't use it on the tester.
7.3? No, 7.
7.3. Oh nope, 7.2. You're right. I'm wrong.
So we're taking 7 input channel 2 data and doing what with it?
Dividing it by 31,206.
Yep. Then what? Wait a minute, time out. What does that give us?
That gives us a percentage, sir.
Very good. Percentage. Now what?
Then you take, I don't remember the math, so we're going to put in the numbers. 31206 minus 6241.
Yeah, and then add 6241 after that expression.
Okay, before I do that, what are we doing with that number? Are we adding it, multiplying it, dividing it, subtracting it?
Dividing,
Multiply.
multiplying.
We have a percentage. We're going to multiply it times the second range.
Yep. Hey,
And what-
bud, could you stop dying over there? Thank you.
Then what are we doing?
Then you are subtracting 6241.
Subtracting it?
No, dividing it?
Adding it.
Adding it. Not bad. I'm looking at a completely different formula on my screen, sir. I'm looking at the, I got one that's like x2 minus x1 times y3 minus y1 over x3 minus x1. I guess plus y1 would work, yeah. It's
I
the
think
same.
that's just interpolation.
Yeah, that is. And then the destination, wouldn't it be a float?
Yep. I don't know what we got in here. I'm just going to pick one. F8. F88, just for this example. Okay.
And then I would,
Move function.
then a move function, 2 move functions actually, but on separate rungs. We need one for the float number and one for 6,000, so we could shut it off.
F88.
Yeah, F88 right there. Destination, my heart. No, channel 1, modular 6, channel 1. Will be the destination. Oh, wow. You actually put my heart.
Yep. Happy Valentine's Day.
Thank you. Is that recently? I don't think it was. February, so no.
Okay. So if this is the case, if I make that water level rise, the temperature fan should go higher and higher. Now this all looks good to me. The only other things I'm going to add in here is that drive enable deal.
The control bit.
Yeah, I don't know if you may or may not know what I'm doing. You don't need to know what I'm doing, but I'm just bypassing the drive enable. If you want to know, ask me later.
Shouldn't we also make a move function for 6,000?
On the move function already says 6,000. That's why I didn't ask. I didn't know if that was like something you had to input.
Just a second. Let me think about that.
Yeah.
Oh, it's 2. No, no. So what do we want to do? We want to move the number 6,000 in there when
We get a read on the distance sensor.
I don't think we need that because with this in there live updating, it's never going to be below 4 milliamps. You know,
All right.
we're never going to put anything below 4 milliamps on that drive with this running the way that it is. All right. Selector switch is off. Do you want to put a couple rungs in there that show what the distance is or what the height is? Or you want to just run it and see it work?
Maybe we could do both.
Okay. You want to run it and see if it works? And then we'll put a couple rungs in there, one that shows hertz and one that shows level.
Yeah.
All right, that's a good example. That'd be a good example for the final. Let's run this and see if it works, and then we'll add those rungs. So right now we're at 0 hertz, which means the level sensor must be all the way down. So I'm going to run the left pump with the selector switch. Can you guys see what's going on or no?
We can, well, at least I can see.
We should be
Okay.
putting up at the 0 level for the distance sensor. So if we did this right, you should start seeing that number go up. And yep. So now the fan, I'm going to stop it, is at 18 hertz. Can you see the fan going?
Yeah.
All right, now I'm going to start raising the level of the water some more, and you should see that fan speed go up. I know you can't see the drive, but I'll just tell you 20, 25, 30, 35, 40, 45, 50, 55. So that right there is at 58 hertz. You can see we're almost to that yellow line, which is the high value of that distance sensor. I'll just put it at 60. So that's full speed, right? And then if I run the right pump and start to empty that, you'll see the fan speed go down as well. Starting to slow down, 55, 50, 45, 40, 35, 30 hertz, 25, 20. I'll stop it right there. Back down to 18 hertz. Cool?
Cool.
We don't have a way to stop the process. I guess I can let that run while we. Figure this out. Actually, I'm going to put it down to 0. Okay, 0 hertz. All right. So what are we doing? We're adding some rungs. We're adding some rungs. What do we want to show with these rungs?
Wasn't one of the hertz on the VFD.
Hertz on the drive and
Don't know the other one.
the level.
All right. Yeah.
Let's work on level first. We're going to interpolate. So what are our numbers for level? It's crunch time. It's final exam stuff.
Probably 4 to 20 milliamps.
Well, what are we reading for the level? What's going to give us our level value?
Is it the 6241 to 31206?
Nope. So,
It's the 0 to 31.
right.
Okay,
Yeah.
0. I didn't know if it was 0 or 6,000.
Yep. So think about it this way. What on this trainer is going to give us the number we need? It's going to give us level. What's going to tell us what the level is? What component on here is going to tell us what the level of this tank is?
The distance sensor.
The distance sensor. And this distance sensor happens to be, I mean, you could look up the information for this. But I'm telling you, it's a 0 to 10. What's 0 to 10 volt? Let's see, who is that?
Jacob.
Jacob, are you there?
Yeah, I'm here.
Can you mute yourself when you're not talking?
Oh, yeah. Yeah, I'm sorry. I forgot to mute it back up.
Okay. I can do it for you. I just feel mean, like, I will mute you now.
Right. No, if I ever forget to do that, just say something or just mute me. I'm on a job, so sometimes it's banging around.
That's what I figured.
So.
Okay. Blue,
Okay.
black, purple. All right. So we know that distance sensor is going to give us 0 to 31206. So that's our input. What's our output?
0 to 60.
We're talking level now.
Oh,
So, like a percentage, would it be?
We're going to turn this into a percentage.
Yeah, but
what? I think he's questioning what our output would be if it's not 0 to 60 or like.
We don't.
Because we don't have like inches.
Oh,
Yeah.
You're right. Okay, you're right. I need to measure that. Let's call it 2.5 inches. 0 to 2.5. So here's our distance sensor. And we want, this is going to be level. So in order to get level, we've made it a formula. Level equals go.
So it'd be
our
I'm
number,
thinking, yeah, it'd be the
So-
distance.
whatever it is, divided by 31206.
Yep. Divided by 31206. What does that give us?
A percentage.
Yep.
Times 2.5.
Times this range, which is just 2.5 minus 0, which is 2.5.
And that's it because you're supposed to add 0, but
Right. Okay, so there's our level. What would be our hertz?
Would the range just be 0 to 60 on Hertz version?
Yeah,
But
it'd be the same.
and aren't those the 31206 to 6241, right, on the VFD?
Yes, but we're not worried about that. All we're trying to do is spit out a number between 0 and 60, right? So if we had this percentage and we're applying it to that range,
So instead of 2.5, it'd be 60.
yeah. So level would be this, and then hertz would just be the same thing, distance divided by 31206. Times 60. I'm going to say one more thing before we actually put it into logic. How many times now have we had this in our formula? Distance divided by 31206.
3 times.
Yep, 3 times. Once here, and once in our other formula. So for the final, could you, and I hope I'm not confusing you too much because I don't care which way you do it, but could we just take distance divided by 31206, assign that to an F8 number and call that percentage?
yeah.
Label it percentage. And then we could take that percentage and apply it to whatever we want to.
Yeah, you can make that a compute function.
However you want to slice it. right? So if you had this distance divided by 31,206 as an F80, and you label that F80 percentage,
What functions will we use to multiply it in?
well,
The compute.
all you're going to do, like in this case, is if you're trying to find hertz, you're going to take F80 times 60.
Yeah, what function would that be?
F80 times 2.5. For what was this? Whatever this one is. Distance divided by 31,206. So that's what the F80 would be, times 31,206. So if that was the case, if you had done that, you would take F80 times 31,206 minus 6241 plus 6241. See what I'm saying? There's more than one way to do it. You can break it down as many slices as you want, however you're comfortable with it. Okay? But for now, we'll do it how we just calculated it. So what was our first one? Use level. What's our formula?
It was the 0 to 31,206. So it was our distance divided by 31,206.
Times 2.5.
2.5 over 0.
So distance sensor divided by 31,206. That gives us our percentage. And then what are we doing?
Times 2.5.
Yeah.
Times 2.5. What are we going to do with that number for the destination?
Are we trying to read it on? Or do we?
No, we just want to keep it in a float. Yeah.
Yeah, that's all we're doing is displaying. We're using this rung to display what it is. So here, which float it is. I'm going to call it F80. And I'll just label this level in inches. And then what? Now we're going to find speed in hertz.
So that same formula, but times 60.
Correct.
The easiest thing to do here would be
If we had a separate float.
copy that, paste it here. We'll make this F81.
Does the
This formula, then all we have to do is change this to times 60, right?
right? Does the temperature sensor have the same 0 to 5 volts, 0 to 31,206?
Nope. What is the temperature sensor? What kind of signal is the temperature sensor putting onto the VFD?
Oh, 0 to 10 volts.
Nope. To the
Oh, 4 to 20 milliamps. Sorry.
yeah. So the temperature sensor, this thermocouple goes to that puck, and that puck takes that signal. So a thermocouple uses a difference of voltage, right?
Yeah.
between two dissimilar metals. That puck will take that signal and turn it to a 4 to 20 milliamp signal,
Okay.
depending on if it's 0 to 100 degrees Celsius, just for that puck. What am I doing? Oh, speed and hertz. All right, so if we did this right, this should show F80 the level in inches, and this should show the speed in hertz. Should we try it?
Yeah. Follow-up question. Is everything that's 4 to 20 milliamps going to be the 61208 to 30? I have it in my notes.
31206.
Perfect. Yes.
I want to answer that question. What do you think?
I think yes, because I don't have it in my notes. The only thing I have in my notes is that 0 to 5 and 0 to 3, 2105. So I'm assuming anything that starts with 0 will be 0 to 31206, and anything that starts with 4 will be the 6241 to 31206.
Let me answer your question this way. You're probably right, but if you wanted to double check that, where would you look? How would you find that information?
That is the question I think I am asking. Would I go to the tags?
Yes, and then Google those cards. It's like
It's
1769.
all in your. It's all in the Rockwell user manuals, every bit of it, and in the user manuals.
Yes.
The user.
So go on like your tags, and it'll be like, for instance, I think one of them's like 1769-OF2. Google that, and if it's an analog signal, it'll give you the reading.
Let me answer.
Or you just pull it out
In my
with
hand.
text.
What is this?
That is a
Let's see.
Rockwell Slick 500.
It's not a Slick 500. What is this?
I'm sorry, a Micrologix 5000,
It's
right?
not Micrologix.
Whoa, what is it?
I'm not going to tell you. Somebody tell me what this is. If you say PLC, I'm gonna not like it.
I can't see it super good, but I know we've been working with the compact.
Compact Logix PLC. This. Okay, I just unlocked it. I'm gonna slide this bad boy out. This is, if you can read it. Probably not. This is an analog input module. Can you see the number down here?
Yeah.
If you go type this number into Google, it's going to pull up this. What does this thing do?
Reads analog signals.
Yeah, it receives an analog signal, whatever that signal is. So depending on where you land your wires, if it's a 0 to 10, 0 to 5, 4 to 20, right?
Right.
If you're using a 4 to 20 milliamp signal, so let's say the puck, the temperature puck. No. If you're using a 4 to 20 milliamp signal, this thing will show you some numbers in the software, right? So if you Google this thing, this manual, and I can show you what that looks like. I did a couple weeks ago, but this will show you what, if you have this signal, what numbers will you see on your software.
Okay.
It just depends on the module. Okay, this thing will take 4 to 20 milliamps, and it will show you 6241 to 31206. It will also take 0 to 10 volts. If it does that, and you tell it that's what to look for, it will show you 0 to 31206, right?
Okay.
Sense?
Yes.
Okay.
And you can do all that when you're configuring the cards, correct? You can choose whichever input you have.
That's right. So that module that I just held in front of you, is this 1769 IF4. So I'm going to open that up. You remember this screen where we disabled the keying, and then over here in configuration, we told it, look, channel 2, that's a distance sensor. It's going to give you module. This is going to give you 0 to 10 volts. And we told the temperature, we told it, all right, channel 3, I've landed a temperature sensor. It's going to give you 4 to 20 milliamps. So we told it that. And then it's going to say, okay, thank you for that 0 to 10 volts. Here's a number for you. It's going to be between 0 to 31206. Make sense?
Yep.
All right. We got this thing running. It looks to me like it's working. We'll just double check. Right now, the speed is basically 0. The level is basically 0. And we will make level go up. So I'm going to turn pump 1, left pump on. And you should see the level in inches start to go up. And you should see the speed in hertz start to go up. So I'm going to stop it around 1 inch. So I'm around 1 inch, and the speed of the fan is 27 hertz. And that's pretty spot on. 27.7 is what the drive is showing. Huh? That one what? We're gonna make the water go from there into there. You ready? Yep. Okay, and now I'm gonna keep going with the level. And we're at 1.5 inches. I'll stop it at 2 inches. 2 inches, and the speed of the fan is at 50 hertz. Cool?
Cool.
All right.
Cool.
Didn't even get into the HMIs, and I even like set up this fancy schmancy I'm gonna turn this fan off here. We didn't even get into the HMI to finish that up, but it makes me sad because I set up this really, some of you saw at the beginning. I did that just for you guys, and I didn't even get to use it.
Looks great.
Maybe we'll do that Wednesday.
That'd be cool.
After our quiz.
Yeah, isn't the quiz Wednesday?
Quiz Wednesday.
Yeah, but the quiz will take
You sure you want to?
You want to answer that?
Nathan, put yourself on the spot.
Nope.
How long will
I
it
shut
take?
up for a reason.
How long is that gonna take, Nathan? Oh, you're just funny. All right. Any other questions?
Nope.
Okay.
Bye, guys.
You guys have a good rest of your day. Can you say goodbye?
You too.
Look on the
Bye.
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 Our quiz is Wednesday, right?
Yep.
All right. That's just over the motor, and we need to just remember the formula.
We reviewed for the quiz on last Wednesday.
Yeah. Yeah, I got all my notes for it.
That's and then it's on YouTube too if you want to review.
Okay.
All righty. You have a good day.
Who's still here?
Huh?
Oh, who's still here? My headset died. Sorry.
Okay. I'm here. That's all that matters.